Welcome back to the Foundation in C# course. We are currently in Module 7, and this lesson we're going to be taking on a mini project. And in the past, we've done things a little bit differently, where I've given you the project and gone through and done it, and then giving you some more homework to kind of do it yourself. Based on a user suggestion, which I think is a great suggestion, we're going to flip that script. So I'm going to give you your homework now, and then you can pause the video and do the homework yourself, and then come back and play the video, and you'll see me actually complete the homework. So since I don't normally do homework, this is the way to kind of show you that larger bit of homework being done, so you can kind of see how I would do it. Okay? So the homework is to build a class library, a .NET standard version of a class library, with a class that does the basic math operations. Those basic operations are add, subtract, multiply, and divide. And then create unit tests for all the methods. And that's going to be more than just 4 unit tests. Maybe you do theories and maybe that 4 methods, but you're going to want to do more than 4 tests, because you want to try to get those edge cases as well. So with that hint in mind, go ahead and pause the video right now and go do this homework. Did you actually do the homework? Are you actually back here from doing the homework, or are you just kind of being lazy and letting me do all the work for you? I would encourage you, if you haven't done the homework, do it, because getting your hands dirty, getting your hands writing code makes a big difference in learning. Just watching it being done, it seems like you're learning, but really you're not. Not until you actually do it. Okay? So if you haven't done it already, pause this video and do it now. All right, I'm going to assume that you're done. So let's go to Visual Studio and create a new project. And we're going to create a .NET Standard Class library. So there's a .NET Standard Class library. And we'll call this library the Calculation Library. And this is the Calculator Unit Test Demo app. You'll hit Create. And this will create our .NET Standard Class library for us. The first thing we do is we delete our class 1. Like so. And now we'll have public double subtract, double x, double y. And then we'll have, public double, multiply, double x, double y. If you haven't noticed a pattern by now, you might want to think about it a little more. There's quite the pattern here. Public double divide, double x, double y. And now there's our 4 method stubs. Now right now they're all yelling at me because not all code paths return a value. Now we could let's do this. Throw new not implemented exception for each of them, because that technically fulfills our requirement, but at the same time, it will make sure that we don't assume these are working. So I got these 4 method stubs now: add, subtract, multiply, and divide. Now I can create my test. So right click on tests, say add new item. It's a class, and we're going to call this class calculations tests. We'll make it public. And we're going to have a using statement up here, using X unit. So we can have our, let's do a theory right out of the gate, because we know we're going to pass in more than one parameter set. So public void add should return expected value. Okay, pretty vague here. Double X, double Y, and double expected. Like so. So now we have our 3 variables. Now we can do our 3 parts. The first one is that we need to arrange. So let's just put this right here. And we'll put our act and our assert. So, arrange. What are you going to do first? Well, we need to have a reference to calculations. Calculations, control dot. If we notice here, there is not a way to do that yet. But if we right click on dependencies and add a reference to our calculation library, now if we control dot, well, there you go. Don't even have to do that because we're in the same. We can go ahead and declare it right away. So now we have access to that. We can say just calc equals new calculations. That's the arrangement part of things. We already have our expected value. So now we can capture our actual value. Double actual equals calc dot add X and Y. And that should return our value. We can check that by saying assert equal our expected actual. Notice how simple that method was? It just seems to work. Now, theories must have test data. So that's why it's still yelling at us. No problem. Inline data. We have, let's start with something simple. 4, 2, 6. So 4 plus 2 equals 6. And that should work. Let's save this, open our Test Explorer, which it's discovering the test once we do the build. So we'll pin this over here. It's got one test. It's running the test currently, and it fails. So if we click on it, it says message was not implemented exception. Okay, so we tried to run this and it failed, saying we have a not implemented exception, which is actually cool because that's exactly what we have. So let's write some code to make this work. This is a test-driven development type process, red, green, refactor. So we wrote the method stub but didn't put anything in there. We tested it and of course it failed. Now we'll write just enough code to make it pass. So return X plus Y. Once I save that, I can come over to my Test Explorer and I can run it again. And this time it should pass. And in fact, it does. Now I have a passing unit test. And it's testing 4 and 2. Let's test a few different cases just to make sure that, let's So let's try 0 and 0. It seems like 0 and 0 would probably equal 0, but let's make sure of that case. And then one more, let's pass in 1, 2, 3, 4, and negative 1, 2, 3, 4, which should equal 0 as well. So we're trying negative numbers, we're trying zeros, we're just trying different use it. And now I'm going to do the same thing with multiply. And let's change this to multiply. I'm going to do the same thing again with divide. Now, copying and pasting is always dangerous. I'm doing it to save us time in this demo, but be very careful with copying and pasting. It's so easy to miss one little thing. So for example, if I said divide up here, but I was actually calling the multiply method, that could be an issue, and I might not spot it. So make sure that you are careful of that. All right, inline data. Let's actually just copy one of these. Let's copy a simple one. And just change the numbers. So the first number for subtract, let's do 8 and 2 is fine, and that would be 6. 8 minus 2 is 6. And then let's put a few more in here for edge cases. 0 minus 2 should be negative 2. Let's add another one. How about 9 minus negative 2, which actually will be 11, because subtracting a negative is adding. So 9, basically 9 plus 2. So if you're still struggling with math, get your calculator out and make sure these are correct, and before you actually run them. All right, multiply. 4 times 2 is 8. Let's see what else can we multiply. 40 times 0 is 0. And let's see, what else can we do? 9 times 9 is 81. Now for our divide, 4 divided by 2 is 2. And then we can have, let's try and keep it to whole numbers. Let's not, or at least not, we shouldn't do 1 divided by 3 or something like that. That would be ugly. But what if we did 1 divided by 4? That should be 0.25. That can happen. And then let's do 6 divided by 2 is 3. Let's leave it there for now. I know there's more tests in here. I'm intentionally not putting that test in yet. Now we have a whole bunch more tests. If we run these, we get 9 failing tests and 3 passing tests. So add, they're all passing. Divide, multiply, and subtract, they're all failing. So let's change these. So subtract is return x minus y. Oops, minus y. Now if I copy and paste this in the next two, And I go, okay, divides actually divide like so, and I leave it. And you may have noticed I made a mistake. But let's just see how nice this test-driven development is, because it knows that I left a mistake, and it said, yeah, multiply is not right. You go, what's wrong with multiply? Oh, I forgot to change that. And so I changed that, and now when I run this, it should be that all 12 tests pass. Wait for it, wait for it, wait for it. Something's clogged up here. It's still building. And there were build errors. Do you want to continue the last note? No, I do not. So we had a build error that's uncommon. Let's do a rebuild and see if that fixes the problem. Okay, so we're still getting errors. And if we scroll down here, could not copy this DLL to the bin debug, exceeds retry count of 10, failed. The file is locked by .NET Core host. So there's something going on in Visual Studio itself. So what we're going to do is we're going to close this down and we're going to restart. Okay, I've restarted. Now let's try this again by doing a build. And the build is currently running. We'll see if it runs. I could have cut this out of the video, but I wanted to show you because if you panic over an error, that can be problematic. And I want to show that, panic, it's not helpful. So instead, we got to figure out what the problem is and what we can do to fix it. So in this case, it's still saying we have errors. Let's turn off the warnings. Could not copy the bin debug standard, the calculation library.dll to the .NET Core 3 calculation library.dll exceeds retry count of 10. And it's still being used by another process. So it can't access that DLL. So something's clogged us up and is accessing our DLLs. So here's what I'm going to do. I'm going to open this in File Explorer. And I'm going to go to first of all, my tests and go to bin and just delete the debug. And I can't. So there's something holding on to that. Let's look inside here and see if we can see what might be going on. I don't see anything. That doesn't mean it's not there. So what I'm going to do now is I am going to close out Visual Studio and try and delete that debug again, and it's still being locked. So something is locking our files. Okay, so the next solution here is going to be for us to restart the computer. Something is holding on to that DLL, but we don't know what. So I'm going to pause the video. I'm going to restart the computer and come back to this. And by 0B. Well, let's write a test for it. So 15 items, that's what you had, right? Yep. And I had 0 to divide by. What should that be? Should it be 0? Should it be something else? If you don't even know, and you don't know what the answer should be, then that's a great time to write a test. Because until you figure out what the answer should be, you don't even know how to write a test for it. If you don't know how to write a test for it, you sure don't know how to code it correctly. So now we have a test, and we say it should probably be 0 that it returns. Let's see if in fact that's what happens. We run this test. We should have 13 tests now. And in fact, we have one that fails. We check to make sure. Sure enough, we have one divide test that fails, and it expects 0, but it actually got infinity. So what are we going to do here? Well, if this is what we expect to have happen, but it's not what happens, and divide by 0 probably shouldn't return 0, but maybe in your use case it should. So in this case, what we could do is we can come over here and say, oh, we need to fix this method because we've got a failing test. It's not returning 0 in the case of divide by 0. Now we have our failing test, we can go and make a fix. So we can say, well, this isn't gonna cut it, so let's do this. Let's have a double output equals 0, and at the very end return output, but we need to do some work on it first and actually do the division. We can't just say output equals x divided by y because of that 0 issue. So if y is not equal to 0, then output equals x divided by y. So what's going to happen? Well, if it's going to start off at 0, if y is not 0, that's divide by. So if y is not 0, do division and put the value into output. But if y is 0, it's not going to do this, therefore it's going to stay with the default, which is 0. And to return that. Now if we run our test again, we should see that our tests all pass. So we had a bug, we wrote a test for that bug to reproduce it, and then we changed our code so that our test would pass. So we'd fix the bug. But not only that, we still are testing the other divide methods, the ones that already worked. Because if we somehow wrote this poorly, then all the other tests would fail, or some of those other tests would fail. And it would indicate to us that while our bug fix may be the right solution, it's not the entire solution because we're now failing other parts of our test. So in this short demo, we've seen how to follow after TDD, or test-driven development, where we write our tests before we write our code. And we've gone and done the red-green refactor, where we had the test fail, then we made the test pass, and then if we needed to, we could have done refactoring. Now, we didn't need to in these very, very simple methods. Now that we have this in place, and by the way, I did kind of skip a TDD testing in that I wrote more than one test at once. Now, TDD would say, write one test and say 1 plus 1 equals 2. And then for your add, instead of doing return x plus y, you'd return 2, because that technically fulfills the test. Yeah, it does. But I prefer not to write code that I know I'm going to have to redo. So, because the idea is, okay, now write another test of 2 plus 2 equals 4, and of course that will fail because it's going to return 2, not 4. And you say, okay, now make that test pass. Well, the result of all of that iteration is going to be return x plus y. So I just got to the heart of the matter and wrote what I thought was the correct value. So I did skip a couple of steps in the TDD standard process. But that's generally how you'd follow after test-driven development. You write your tests, make sure they fail, and then write the code to make the test pass. And then, if necessary, refactor your code to make it better. And the same thing was true when we had a bug. The user gave us a bug, and we reproduced that bug by creating a test that would do the exact same thing. Once we got that test and figured out that, sure enough, that test fails, we've reproduced it correctly. Once we did that, then we could go and create the fix in our code and be assured that we hadn't broken something else. So that's kind of the power of these unit testing projects, is we can really make sure that we're comfortable with our code and make sure that if there is a bug, we can reproduce it, and then we can fix it and be assured it is truly fixed. Okay, so that is the the homework, that's what you should have done. Hopefully you did, and hopefully it looks something similar to yours. Maybe you didn't get the divide by zero issue covered, or maybe you did. But either way, hopefully you learn from that, and if you didn't do this, go back and try it with yours. Write a failing test and then make it pass. So let's talk about today's tip. And the tip is to test more than just the perfect case. So this is a rookie mistake. When you have a divide by method, you say, 9 divided by 3 equals 3, it passes. 4 divided by 2 equals 2, it passes. Cool, we're all good. Well, don't just test the perfect case. Test all those imperfect cases, and test those most of all. The things that are just on the edge. The things that the user might give us that we wouldn't think are normal answers. So if you ask for what is your age, make sure that you're testing for what happens when you get a negative age. Okay? So in our methods, we tested for things like negative values and zeros and those type of things, because those are our edge cases. There's not a ton of edge cases for add and subtract and multiply, especially. There's only really one for divide. But definitely test those edge cases, because that's where you're going to find your bugs. Okay? So hopefully you got that homework. Hopefully you kind of follow along and had done it beforehand and really grasped it. Once you are comfortable with what you learned in this lesson, go ahead and move on to the next lesson in the course.